Good morning. I am presenting a study of stamping die design using software simulation. As a result of development in Indonesia, the growth in automotive industry has a significant advancement. This also brings growth in automotive part suppliers, including the stamping part for automobile body. The main equipment for this stamping part is stamping dies, and the stamping dies will be used in the stamping press machine. Most of these automotive part companies, they do direct testing on machine when they make a new stamping dies. And of course, it needs about 7 to 10 trials and takes about 3 to 5 days. There is a rising question whether any other way to speed up the process. One alternative is by doing the simulation prior to making the dies. Die geometry and stamping parameters play an important role in preventing the defects. So these need to be identified before we make a new dies. And one of the ways to identify this defect can be through a simulation. This study was conducted to find out a proper CAD model geometry for stamping die design by taking into consideration the result from software simulation. By doing simulation, it is expected that the number of trials can be minimized. The method of this study, starting with doing scanning on the final part or final step part, and the result of scanning was stored for reference. And then run simulation on original 3D CAD model of original design. Then analyze the result. If there is any defect, then we modify the CAD geometry. In order to modify this CAD geometry, we use the scanned part as the reference that has been scanned. After modification, run the simulation again, then analyze the result. If there is no more defect, then the process is finished. From the scanning process, we get the scan result that shows the deviation from the original part. The blue color part is the original design, and the yellow color part is scanned result. There are some deviation or discrepancy from the original part, especially in the corner radius as well as the spring back. Before we run a simulation, we need to determine the blank holder force. If you look at into this picture, this is the dies, and this is the punch, and this is the blank holder or binder. And we need to find out how big is the holding force that is significantly influence the stamping result. In order to determine the blank holder force, we need to know the punch force. The material of this part is SPCC 440 that has the yield strength of 245 megapascal. By using this formula, we can calculate the punch force Fp here by including the circumferential of the part multiplied by the thickness, multiplied by the yield strength, and multiplied by sine theta, where theta is this bend angle. Similarly to this other side of the part that has a different theta angle here. The result of punch force is 636 kilonewton, and bank holder force is calculated based on 34% of punch force, which is 216.26 kilonewton. In the simulation, we can get the blank sheet form, the forming limit diagram, safety zone, forming zone, thickness strain, and spring back. The result of the first simulation, we got the blank sheet form. The left side here is the result from the simulations, and the right pictures here, blank sheet. On the original part design, the simulation result shows that there are mostly has safety zones here, but there are some wrinkle tendency zone that is in the light blue color and dark blue color. If you look at the forming zone here, there are several areas that has a strong wrinkle tendency, as well as some tight panel that tends to split. The result summary can be seen in this table. It says that this part has a strong wrinkle tendency. Therefore, we run again the simulation and the part was modified. The modification mainly on the radius of this cone as to minimize wrinkle tendency. We run again the simulation and the result shows that the wrinkle tendency is less than before. Similarly here, we look at into the blue color is also less than before. The spring back also shown that in the modified part, the red zone is less than the red zone in the original part. And finally, we run the thickness strain simulation. And finally, we look at into thickness strain. The initial part thickness is 1.6 millimeters. There are some area that has a lower thickness and other area that has higher thickness here. So it's ranging from yellow, which is about 1.4, up to 1.6. In order to validate the simulation result, we did measure the actual part and compare with the simulation result. In this part, we found that the thickness is 1.59 and in the simulation it is 1.58. There are 7 areas that was compared, and the difference between simulation and measurement is from 0.63% up to 6.25%, and the average deviation is 3.89%. In conclusion, the scan data shows that the actual stamp part is resulted from a modified stamping dies geometry. So it is shown from the scan result that the actual stamp part has the deviation from the original design. The simulation on original CAD model shows that there is a strong wrinkle tendency, and therefore we modified the part to run the simulation again. The modified model simulation shows a good result indicated by better forming limit diagrams, forming zone, thickness strain, and thank you very much for your attention.